Alright, let's look at this one. A vertical electric pole was erected 6.4 meters from the foot. The word here is there, not here. Okay, from the foot of a vehicle fencing pole on the same horizontal level. So first thing, we need to draw that vertical electric pole. Let's just draw that vertical electric pole here. So if this is my electric pole, and then there's another fencing pole somewhere there. Now according to the question, it means that let me draw it a bit straighter. Okay, now according to the question, it means that the electric pole here, so this one is the electric pole, and this one is the fencing pole. Now the distance, so the electric pole was erected 6.4 meters from the foot of the vehicle. So from here, so it means that from here, let me use a straight line. So it means that from the fencing pole here to the electric pole, that distance there is 6.4 meters. Now the fencing pole is 2 meters high, so here again the fencing pole is 2 meters, so that is from here to the bottom is 2 meters. The angle of elevation of the top of the electric pole, so this is the top of the electric pole, so we are being told that the angle of elevation of this point here from the top of the fencing pole. So the word from tells us where do we stand. So here is where we stand, from the top of the fencing pole. So here is the top of the fencing pole, so here is where we stand, and then draw that angle of elevation. Yeah, so if I can draw an imaginary line here, sorry. So if this is my horizontal line, then it means that the angle of elevation is that line there. So it means that the angle of elevation is that angle whereby you raise your eye. Elevation means raising your eye, and that one is 30 degrees. Now the question is, determine the height of the electric pole correct to 1 decimal place. So what will be the height? What will be the height of that electric pole? So what will be that height? That height is what we are asked to find. Now, so this is very simple. I'm just going to draw I'm going to complete that horizontal line, and this horizontal line makes an angle of 90 degrees at that point. So it means that if from here to here is 6.4 meters, then it means also that here to here is also 6.4 meters. So I'm going to extract this figure. I'm going to extract that triangle and draw it there. I'm just going to sketch. I'm going to sketch that triangle, so that here is 90, here is 30 degrees. Yeah, as is evident from here. Now this distance is 6.4 meters. Now I want to get this distance here, x meters. I want to get that distance from here to here, which corresponds to this distance from here to here, x meters. And of course we know that from here to to here is the same as from there to there, which is 2 meters. So what I need to calculate is this distance from here to here, that is x meters. So to calculate that distance, you are going to use the formula tan theta is equals to opposite side over the adjacent side. Now the angle theta here is our 30 degrees. So tan 30 degrees should give us, so which side is opposite to that angle? The side which is opposite to 30 degrees is x meters, and then the adjacent is now that 6.4 meters, from which now our length x meters is going to be, you take 6.4 times tan 30 degrees, so which is 6.4 times. So from your calculator, the value of tangent 30 degrees is the same as 0.5, not 5774 approximately, that one, from which if you multiply the two, you will get approximately 3.69. One is 3.695. So the value of x is 3.695 meters. Now the height of electric pole, so height of the electric pole is, now you take that x meters, you add to 2 meters, that is here is the x meters plus 2 meters give you the total height of the electric pole. So this one is the same as 3.695 meters plus 2 meters, which is the same as 5.695 meters. Add to one decimal place, this is approximately 5.7 meters. So this is how you calculate such a problem. If you like this video, make sure you follow my Facebook page, like and share with your friends.